In the previous video, we talked about uniform distribution and binomial distribution. Now, in this lesson, our focus is on geometric distribution. There is a notation for this. X follows geometric P, where X is the number of trials to get first success, and trials are independent and identical. P is the probability of getting first success in xth trial. Okay, and the PDF, or the probability of getting first success in xth trial, is q to the power x minus 1 times p. This is the probability of failure until x minus 1 trials, and this is the probability of success in the next trial. So it is for sure that you'll have success in the xth trial. Now let's look at the mean and variance. So mean is 1 over p and variance is q over p square. Let's derive mean and variance one by one. So the basic idea of expectation is summation x times probability. X ranges from 1 to infinity. And also I forgot to mention here, the range of x is 1, 2, 3 up to infinity. X equals to 1 means you can have first success in the first trial, first success in the second trial, first success in the third trial, and so on. So now summation x equals to 1 to infinity x times p times q to the power x minus 1. Okay, now you can bring q outside of the summation. So this is p, and you can put the values of x inside the summation. So you'll get 1 plus 2q plus 3q square, 4 to q to the power cube, and so on. So this is expectation of x. Say this is equation 1. Now let's multiply equation 1 with q on both sides. So p q plus 2q square, 3 cube, 4q to the power 4, and so on. Say this is equation 1. Now subtracting equation 2 from equation 1, we'll get expectation 1 minus cube equals to p. Let this 1 be as it is, and then we can subtract these terms. So this is q plus q square plus cube plus q to the power 4, and so on. Now expectation of x, this is simply p, and this thing is nothing but the sum of the infinite series of geometric. So this is p times 1 over 1 minus q, or let's write 1 over p. Okay, so we can cancel this p, so we'll get expectation equals to 1 over p. All right, now let's look at the variance. So variance of x is expectation of x square minus whole square of expectation. We know this, we need to calculate this. So expectation of x square, the basic idea is same, x square times probability of x. X goes from 1 to infinity. So summation x equals to 1 to infinity x square times p times q to the power x minus 1. We can bring p outside. So this is expectation of x square. Bring p outside of the summation. So summation 1 to infinity. This is x square q to the power x minus 1. So this is, we can put the values of x now inside the summation. We'll get p 1 plus 4 cube q, 9q square, 16q to the power cube, and so on. So this is equation 1. Now let's multiply equation 1 by q on both sides. So expectation q is x square, p q plus 4q square, 9q to the power cube, 16q to the power 4, and so on. Say this is equation 2. Now subtracting equation 2 from equation 1, we'll get expectation of x square times 1 minus q, and we can take p common from the right hand side, and then we'll get 1 plus, so this 1 is same, and we can subtract these terms. So 3q plus 5q square, 7q to the power cube, 9q to the power 4, and so on. Okay, and this is simply p, so we can cancel this term. Expectation of x square is, now we can write this thing as 1 plus 1 plus q plus 2q, right? Q square plus 4q square, q cube plus 6q cube, and so on. Okay, now expectation of x square, the upper series is simply the sum of infinite geometric series. So this is 1 over 1 minus q plus 2q plus 4q square plus 6 cube, and so on. So expectation of x square is 1 over p, plus we can take 2q common, so this is 1 plus 2q plus 3q square, and so on. So this is expectation of x square, 1 over p plus 2q times, now what is this? Let me show you. Okay, so this is same, right? 1 plus 2q plus 3q square, and this is nothing but expectation divided by p. So we can write expectation of x divided by p, and this is 1 over p plus 2q times, expectation of x is 1 over p, so this becomes 1 over p square. So this is 2q plus p divided by p square. Okay, now the variance is expectation of x square minus expectation of x whole square. So this is 2q plus p divided by p square minus 1 over p whole square. So this is 2q plus p minus 1 divided by p square. We can write p plus q minus 1 divided by p square. P plus q is simply 1 minus 1 plus q divided by p square. So the variance of x is, we can cancel this out, this is simply q over p square. Alright, so this is how you can derive mean and variance of geometric. Now let's look at one example. If the probability of male and or female child is equal, that is half, what is the probability that a woman's fourth child is her first son. Okay, so this is the question. So probability of getting first success in fourth attempt is 1 over 2 to the power 4 minus 1 times 1 over 2, right? So this is 0.0625. So this is how you can solve the problem of geometric distribution. Now before we end this video, let's look at one more important thing, that is conditional probability. So suppose it is given that there have already been n trials without success. So this is given. Okay, now what is the probability that more than x additional trials are required to get a success? So this is the question. So we can write this in conditional form: x is greater than x plus n, where x is the additional trials and n is the trials without success. X is greater than n. Now you can consider this a and this b. We know the formula: a given b, probability of a intersection b divided by probability of b. Now the intersection between these two events is simply x is greater than x plus n. So probability x is greater than x plus n divided by probability x is greater than n. And this thing is q to the power x plus n, right? Failure. And this is q to the power n. We can also write this as 1 minus p to the power x plus n, 1 minus p to the power n. If we simplify this, we'll get 1 minus p to the power x, which is probability x is greater than x. And we can read this as probability that more than x trials are required. Okay, so from this we can conclude that the lack of success on the first n trials is irrelevant. Okay, so this is the conclusion that we can derive from this. And this characteristic of geometric is called memoryless property. Memoryless property. Okay, now let's look at one example of this property to help you understand much better. So the probability of having a male or female child is equal, that is half. A woman has 2 boys and a girl. What is the probability that her next 2 children are girls? So we have to find out this probability. Now due to memoryless property, we can say that the children she had so far are irrelevant when it comes to working out the probability that next 2 are girls. Okay, so the probability is simply 1 over 2 times 1 over 2, which is 1 over 4, 0.25. all right, so this is how we can use the memoryless property to solve some questions. Now let's stop here. I'll see you in the next video. Thank you so much for watching.